Good afternoon, everyone. So, today we will do exercise 8.1 of application of integrals. We already covered theory portion of application of integrals. So, today we will practice some questions. So, the first question is find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equal to 1. So, to calculate the area, at first we have to draw this graph. Okay, and we know that there are two types of ellipse, which along horizontal major axis, and one is of the type where vertical axis is a major axis, and the equation is of the form x square by a square plus y square by b square is equal to 1, where a greater than b, then it is of horizontal type. ठीक है, where x axis is the major axis. Okay, and if the equation is the type x square by b square plus y square by a square is equal to 1 and a greater than b, then the major axis is y axis. Okay, so at first try to draw the graph for this ellipse and then we calculate the area of the region bounded by this ellipse. Okay, so try. Write down the equation of the ellipse. That is x square by 16 plus y square by 9 is equal to 1. So it is of the form x square by a square plus y square by b square is equal to 1, where a is greater than b. So major axis along the x axis and vertices are plus minus a comma 0 and 0 comma plus minus b. So we need to find the area of the region bounded by this ellipse. So the given equation of ellipse is x square by 16 plus y square by 9 is equal to 1. Okay, so from this equation we can identify a square is equal to 16. Just compare it with equation x square by a square plus y square by b square is equal to 1. We get a square is equal to 16, which imply a is equal to plus minus 4. Okay, so the length of a segment is 4, and this is the length of the semi major axis, and this major axis is on the x axis, horizontal major axis. Okay, Similarly, b square is equal to 9. So the length of the b is equal to 3. That is the length of the semi-minor axis. So the co-vertices of the ellipse is 0, plus minus 3. So now we have a graph of the ellipse. So now we have to calculate area bounded by this ellipse. So to calculate the area, we take a thin strip parallel to y-axis, vertical thin strip, and at first we calculate the area of that vertical thin strip. So, and the area of that is, width is dx and length is y, so y dx. So the area is given by definite integral from the limit of dx, because we take the vertical strip. So limit of x lies between x from 0 to a. So we have to calculate the definite integral from the limit which varies for x-axis, y dx. So we first express y in terms of x from the ellipse equation. So y square 9 is equal to 1 minus x square by 16. Multiply by 9. We get y square is equal to 9, 1 minus x square by 16. Just combine. We get y square is equal to 9, 16 minus x square by 16. Take the square root of both sides. We consider the positive root for the upper half of the ellipse. Okay, so y is equal to under root 9, 16 minus x square by 16. So we calculate the area in the first quadrant. So we take the positive value of y, and when we have the value of the first quadrant, because the symmetric nature of the ellipse, we multiply it with 4 to get the entire area of the region. Okay, so y is equal to root 9 by root 16, under root 16 minus x square, it becomes 3 by 4 under root 16 minus x square. So we write y in terms of x. It can be observed that ellipse is symmetrical about the x-axis and the y-axis. Therefore, the total area of the ellipse is 4 times the area of the region in the first quadrant, denoted as OAB. So if we calculate the area of the ellipse present on the first quadrant, we denote it as OAB. To find the area of the total entire region, we just multiply it with by 4. The area of the so now we calculate the area of the region OAB in the first quadrant is given by the definite integral of y with respect to x from x equal to 0 to x equal to a is equal to 4. So if we observe the first quadrant graph, if you draw the graph of this ellipse, x square by 16 plus y square by 9 is equal to 1, just see the first quadrant. So in this quadrant, take a vertical strip parallel to y-axis. So the length of the vertical strip is y, and the width of the vertical strip is dx. So area, it has rectangle, so area of that strip is y dx. So now we just take the limit of x. So the first line is the vertical axis, that is y-axis, that is x equal to 0, to the last axis of that is x equal to a is equal to 4. So we have to calculate the definite integral from x equal to 0 to y is x equal to 4 of y dx, and that is the area of OB, because definite integral gives the area of the curve which is bounded by x-axis and the ordinates x equal to 0 and x equal to a. So area of OAB is 0 to 4 y dx. Now to calculate this value, definite integral 0 to 4 y dx, at first we have to write y in terms of x, and we already calculated the value of y in terms of x, and that value is substitute the expression for y from equation 1 into the integral, and that value is 3 by 4 root under 16 minus x square dx. So to find the value of definite integral, we just replace y from equation 1, that is in terms of x. So we get definite integral from 0 to 4, 3 by 4 root under 16 minus x square dx, and that is the area of the OAB. And what is OAB? OAB is the area of the ellipse in the first quadrant. Take the constant 3 by 4 outside the integral sign. So area of OAB is 3 by 4, definite integral 0 to 4 root under 16 minus x square dx. And this is the standard form, that is integral root under a square minus x square dx, where a square is 16, so a is equal to 4, and we know the integral of root under a square minus x square, that is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus c. So apply this formula with a is equal to 4. You get area of OAB, that is 3 by 4 x by 2 root under 16 minus x square plus 16 by 2 sine inverse x by 4 from lower limit 0 to upper limit 4. So as we know, to calculate the definite integral, at first we calculate the value of antiderivative, and that value x by 2 root under 16 minus x square plus 16 by 2 sine inverse x by 4 is the value of antiderivative. Antiderivative is nothing but value of indefinite derivative without constant of integration. And when we calculate the value of antiderivative to find the value of definite integral, apply the second fundamental theorem of integral calculus, as here 4 is your upper limit and 0 is lower limit. So according to second fundamental theorem of integral calculus, just put the first upper limit on into this and value of any derivative, and then minus the value of any derivative at lower limit. So we get now evaluate the definite integral by substituting the upper limit and the lower limit. So area of OAB is 3 by 4 by 2 root under 16 minus 4 square plus 16 by 2 sine inverse 4 by 4 minus 0 by 2 under square root 16 minus 0 square plus 16 by 2 sine inverse 0 by 4. Okay. So when we simplify, we get 3 by 4, 2 root under 16 minus 16, that is 0, plus 8 sine inverse 1 minus 0 plus 8 sine inverse 0. And as we know, sine inverse 1 is pi by 2, because 1 is the value of the angle pi by 2, sine pi by 2 is 1. So sine inverse 1 is pi by 2. And sine inverse 0 is 0. So you get 3 by 4, 2 under square root 0 plus 8 into pi by 2 minus 0 into 0 plus 8 into 0. So area of OAB is 3 by 4, 0 plus 4 pi minus 0, that is 3 by 4 into 4 pi, that is 3 pi. 3 pi square units. So the total area bounded by the ellipse is 4 times the area of OAB. Why it is 4 times of area of OAB? As we calculate, just 3 pi is the area of the ellipse present in the first quadrant, and due to symmetric nature of ellipse along x and y axis, so if you want to calculate the area of ellipse for entire region, then just multiply it with 4, so that we calculate for the all 4 quadrant, and that is the area bounded by the ellipse. So total area is equal to 4 into 3 pi, that is 12 pi square units. Okay. So To calculate area of the region bounded by any curves, the first task is to draw the graph, to recognize the graph, what type of graph it is, and try to draw the graph. When we draw the graph, we have an idea how to calculate. We see the symmetric nature of the curve. If there is any symmetry, then we just break the area. Then we don't need to calculate the entire area. We break it into the pieces and just calculate a single piece and just multiply it by any constant multiple to get the area of entire region. As in this case, to calculate the area bound by the ellipse, we calculate just the area in the first quadrant and multiply it with 4 to get the area of the entire region bounded by the ellipse. Okay, and your then second task is we have to take either a vertical strip or a horizontal strip. If we take a vertical strip that is parallel to y-axis, whose length is y and width is dx. In this case, we the length of the area of the vertical strip is y dx. Then we vary the x, but we take the limit for dx, and then we check in the region where for which we find the value of the area. We see the limit for x. So as the ordinate x is equal to a to x equal to b, so we calculate the definite integral from x is equal to a to x equal to b y dx. Y dx is the area of the vertical strip. And then third task is the change the variable y in terms of x, right? Y in terms of x. And then when you write the y in terms of x, just calculate the definite integral. You get the area for that particular part. And if there is symmetry nature, then multiply with it with that constant. As there is we multiply with 4 to get the area of the entire region. You get your value. Okay, understand? So the next question is, find the area of the region bounded by the ellipse x square by 4 plus y square by 9 is equal to 1. Again, a ellipse. So what is the difference from the first question? As here, the equation of the ellipse is x square by 4 plus y square by 9 is equal to 1. So at first recognize what type of ellipse it is. In this ellipse is a horizontal major axis or vertical major axis. Okay, and try to draw the graph of the ellipse, and then take a vertical strip or horizontal strip and find the value of limits. And if there is symmetry nature, so just calculate the area of the first quadrant and according to the limit, and just multiply with that constant to get the area of the entire ellipse. Okay, so try. At first, write down the equation of the ellipse, that is x square by 4 plus y square by 9 is equal to 1. So if you recognize the ellipse, it is of the form x square by b square plus y square by a square is equal to 1. Okay, because 9 is greater than 4. So here the vertical axis y axis is the major axis. Vertices are 0 comma plus minus a, and co-vertices are plus minus b comma 0. A is the semi major axis length and b is the minor axis length. Okay, so we need to find the area of the region bounded by the ellipse. X square by 4 plus y square by 9 is equal to 1. So the first task is draw the graph, and according to the question, that is x square by 4 plus y square by 9 is equal to 1. 9 is equal to 1. So when we compare it with the standard equation of the ellipse, that is x square by b square plus y square by 9, a square is equal to 1, we get the value as here the b square is equal to 4. So the length of b square is equal to 4, that is length of b is 2. So length of the semi minor axis is as represented by a, that is 2 comma 0 and minus 2 comma 0. Okay, and the vertices, that is length, as we can see, the major axis lie on the y axis. So here vertical, it is a vertical type ellipse where the major axis lie on the y axis, and the length of a, that is a square is equal to 9. So a's length of a is 3. So we get coordinate of b is, the coordinate of vertex b is 0 comma 3. So now we have to find this shaded area. Okay, and to get this area, either we can take vertical strip or horizontal strip. So if you take the vertical strip, so vertical strip it from that is parallel to y axis, whose width is dx and length is y. Okay, and the area of that strip is y dx, and as we take the vertical strip and the area of the vertical strip is y dx, so due to dx, we can also known by the dx, due to dx we take the limit of x. So as the ellipse is in symmetry nature from y axis and x axis, we just calculate the area in the first quadrant and multiply it with 4 to get the area of the entire region. Okay, and so so we have to find the value of definite integral to find the value of the area in the first quadrant, that is bounded by the graph x square by 4 plus y square by 9 is equal to 1, and the x axis and the line y axis is given by the ordinate x is equal to a, the line y axis, and the line which is passes from a 2 comma 0 and parallel to y axis, and the line is x equal to 2. So the limits are x equal to 0, 0 to x equal to 2. So limit are 0 to 2. So we, to find the value of this region, we just find the definite integral from 0 to 2 y dx. Clear? Okay. So from this equation, we can identify a square is equal to 4, which imply the length of a is equal to 2, and this is the length of semi minor axis since it is under x square. Okay, and now similarly b square is equal to 9, which imply b is equal to 3. So the length of the semi major axis is b is equal to 3. Why is it semi major axis? Because it is under y square and ellipse is of the form x square by a square b square plus y square is by a square is equal to 1. Okay, and in this ellipse the semi major axis lie on the y axis. So to find the area using integration, we first express y in terms of x from the ellipse equation. So y square by 9 is equal to 1 minus x square by 4. So multiply by 9. So y square is equal to 9, 1 minus x square by 4. So combine terms inside. We get y square is equal to 9, 4 minus x square by 4. Taking the square root both side. And as we find the area in the first quadrant, so we take the positive value of y. So y is equal to 9, root under 9 minus 4 minus x square by 4. That is 3 by 2 under square root 4 minus x square. And that is the value of, if we can express y in terms of x as 3 by 2 root under 4 minus x square. Okay. So it can be observed that ellipse is symmetrical about the x-axis and y-axis from the graph. Therefore, the total area of the ellipse is 4 times the area of the region in the first quadrant, that we denoted as OAB. The ellipse intersect the x-axis at x is equal to plus minus a, that is plus minus 2. So, as the ellipse intersect x is at which point? 2, 0 and minus 2, 0. So, the area of the region OAB in the first quadrant is given by the definite integral y with respect to x, that is y dx, from x equal to 0 to x is equal to 2. So, area of OAB is 0 to 2 y dx. So, we can also take the horizontal strip that is parallel to y-axis, and in this case, to find the area of OAB, we have to find the value of definite integral for the limit of y and x with respect to dy. Okay. Substitute the expression for y from equation 1 into the integral. So area of OAB is integral 0 to 2 3 by 2 root under 4 minus x square dx. Take the constant 3 by 2 outside the integral sign. So area of OAB is 3 by 2 integral 0 to 2 root under 4 minus x square dx. And that is a standard integral formula. We know how to calculate this integral. So this is integral in standard form, that is integral root under a square minus x square, where a square is equal to 4. So a is equal to 2. The standard integral formula for root under a square minus x square is integral root under a square minus x square dx is x by 2 integral a root under a square minus x square plus a square by 2 sin inverse x by a plus c. So apply this formula with a is equal to 2. We get 3 by 2 x by 2 root under 4 minus x square plus 4 by 2 sin inverse x by 2. Upper limit is 2 and lower limit is 0. So now we have the value of antiderivative. So just apply the second fundamental theorem of integral calculus to find the value of definite integral. So by substituting the upper limit and lower limit, so we will evaluate the definite integral. So area of OAB is 3 by 2, 2 by 2 root under 4 minus 2 square plus 4 by 2 sin inverse 2 by 2 minus 0 by 2 root under 4 minus 0 square plus 4 by 2 sin inverse 0 by 2. So when we simplify, you get 3 by 2, 1 into root 0 plus 2 into pi by 2, as sin inverse 1 is pi by 2 and sin inverse 0 is 0. So when we simplify, we get area of OAB is 3 by 2, 0 plus pi minus 0, and that is 3 pi by 2. That is the area of OAB. Okay. And to calculate total area bounded by the ellipse is 4 times the area of OAB. So total area is 4 into area of OAB, that is 3 pi by 2. So total area of the ellipse bounded by this ellipse is 6 pi square units. Clear? Okay. Question number 3 is, area lying in the first quadrant and bounded by the circle x square plus y square is equal to 4 and the lines x equal to 0 and x equal to 2 is either option A, B, C or D. So here in this question we have three things. First, the circle x square plus y square is equal to 4 and the lines x equal to 0 and x equal to 2. So at first draw this all three graphs. The circle x square plus y square is equal to 4 and the lines x equal to 0 and x equal to 2. As we know, the equation of circle is x minus h whole square plus y minus k whole square is equal to r square, where h and k is origin, and here as we can see 0 comma 0 is the origin and r square, so 2 is the radius. So first draw the circle and then lines x equal to 0 and x equal to 2, and then recognize which area we have to find. Just stated the reason in the first quadrant, and by using the definite integral try to find the area. So write down the equations x square plus y square to 4 and the lines x equal to 0 and x equal to 2. So this is the graph. At first we draw the circle x square plus y square is equal to 4, where the 0 0 is the origin and the length of the radius is 2. So the vertex A is 2 comma 0 and B is 0 comma 2, and the line x comma 0 x equal to 0 is the y-axis, the vertical y-axis, and the line x is equal to 2. So we have to find the area in the first quadrant. So the stated reason is the your required area. Okay, so to find this area we can either take a vertical strip or horizontal strip. So the given circle is x square plus y square is equal to 4, and if we take the vertical strip, so vertical strip is that is parallel to y-axis and the length of is strip is y and width is dx, so and the area of the strip is y dx, and in case of vertical strip we see the limit of x. So limit of x in this region is x equal to 0 to x equal to 2. In this this area is bounded by this line, so the limit of x is 0 to 2, x varies to 0 to 2. So to find this area just evaluate different integral from 0 to y dx, and if we take the limit x dx, that is horizontal strip, so length of the strip is x and width is dy. In this case the area of the strip is x dy, and in this case we take limit of y. Okay, and the limit of y is from 0, and the second limit is lie on the curve, and that limit is root under 4 minus x square. Okay, as in the first quadrant, so we take the positive value, and from the equation we can find the limit of y. So the circle centered origin and a radius r is equal to root under 4, that is 2. To find the reducing integration, we first express y in terms of x from the circle equation. So as we express y in terms of x, so we take vertical strip, and we take vertical strip because in this case the limit is easier, that is x equal to 0 to 2. But if we take horizontal strip, so then the limit is complicated, that is y equal to 0 to from this equation we get the equation root under 4 minus x square. Okay, and that is complicated, so we just take the vertical strip. So y square is equal to 4 minus x square. So y is equal to root under 4 minus x square. Why? Because we are considering the first quadrant. So the region is bounded by the circle and the line x equal to 0, that is y axis, and the line x equal to 2. So in the first quadrant, x ranges from 0 to 2. So the area of the region in the first quadrant given by the definite integral of y with respect to x from 0 to 2, that is area is equal to definite integral from 0 to y dx. So substitute the expression for y, we get area is equal to 0 to 2 root under 4 minus x square dx. And this is the integral in the standard form, that is integral for root under y a square minus x square, where a square is equal to 4, so is equal to 2. And the standard integral formula for root under a square minus x square is x by 2 root under a square minus x square plus a square by 2 sin inverse x by a plus c. Apply this formula with a is equal to 2. We get area is equal to x by 2 root under 4 minus x square plus 4 by 2 sin inverse x by 2, 0 to 2. That is x by 2 root under 4 minus x square plus 2 sin inverse x by 2. Now apply the second fundamental theorem of integral calculus to get the value of area. So substituting the upper limit x equal to 2 and lower limit x equal to 0 at the value of antiderivative, we get 2 by 2 root under 4 minus 2 square plus 2 sin inverse 2 by 2 minus 0 by 2 root under 4 minus z square 0 square plus 2 sin inverse 0 by 2. And that is 1 root under 4 minus 4 plus 2 sin inverse 1 minus 0 plus 2 sin inverse 0. So 1 into root 0 plus 2 into pi by 2, as the value of sin inverse 1 is pi by 2 and the value of sin inverse 0 is 0. So area is 0 plus pi minus 0 plus 0. So it is pi square units. And thus the area lying in the first quadrant is bounded by the circle and the lines x equal to 0 and x equal to 2 is pi square unit. And that is your option A. Okay. So in this question, we take the vertical strip, and that is easy to calculate if we if you take the horizontal strip, because here the limit is simple, as if you take the vertical strip, the x ranges from 0 to 2. But if if you observe in the graph, if you take the vertical strip, the limit of y is complicated, as y from 0, the first line is the horizontal line, the x-axis, so its limit is x equal to 0 to the curve of circle, and that is equation for the equation of the curve is we have to find the limit from this equation of circle, and the value of y is, as we calculated, root under 4 minus x square plus minus root under 4 minus x square. And as we calculate the in the first quadrant, so limit of y varies from 0 to root under 4 minus x square. Okay, we can also calculate it by using this vertical horizontal strip, but this is easier than the horizontal strip. Okay, so the question number 4 is area of the region bounded by the curve y square is equal to 4x, y-axis, and the line y is equal to 3 is option A 2, B 9 by 4, C 9 by 3, and D 9 by 2. So here three curves. First one is y square is equal to 4x. Second is y-axis and the line y is equal to 3. So at first you should know what is y square is equal to 4x. How to draw this graph for the curve y square is equal to 4x. So if you know the parabola, this is the equation of parabola. There is 4 types of parabola, which is opening on the right, opening left, opening up, and opening down. The first type is y square is equal to 4ax, which is opening right, and it is of the right form. And the y square is equal to minus 4x, which is opening left side. Opening up is x square is equal to 4ay, and opening down is x square is equal to minus 4y. So this is of the type y square is equal to 4ax. Okay, and the standard equation is y minus k whole square is equal to 4a minus x minus h square, where h and k is the vertex. Okay, and here y minus 0 whole square, h, x minus k, x minus 0 whole square, so its vertex lie on the origin. Okay, so you have to draw a graph for this parabola y square is equal to 4x, then y-axis and the line y is equal to 3, and then recognize which is the bounded region by these three curves, three lines or curves and lines. Okay, and if you set it the region, then think which we have to take a horizontal strip or vertical strip to find the area, and which are easier to calculate. Okay, you can take any horizontal or vertical strip to find the area of the curve, and then use the definite integral to find the area bounded by the curve y square is equal to 4x, y-axis, and y is equal to 3. Okay, so try. First write down the equation y square is equal to 4x, y-axis, and y is equal to 3. Okay, try. So this is the required curve. We draw the curve y square is equal to 4ax, which is opening on the right. Okay, and the vertex is at origin, and the y-axis is vertical axis, and the line y is equal to 3, and the area bounded by this three first curve and two lines y-axis and ay is equal to 3 is area AOB. So we have to calculate this area AOB. Okay, so to calculate this area, either we can take horizontal strip or vertical strip. So if you take horizontal strip, that is parallel to x-axis, so the length of the strip is x and width is dy. So we have to calculate def integral for x dy, and also we have to calculate the limit for y. And here y varies from, if you take the horizontal strip, y vary from the curve y square is equal to 4x to the line y is equal to 3. So to find the lower limit, we have to solve this y square is equal to 4x. So y is equal to root under 4x. And as we in the first quadrant, so we have to take the positive value. So y ranges from root under 4x to y is equal to 3. We can also take the vertical strip. And in case of vertical strip, the length is y and the width is dx. So we have to calculate the value of y dx, and then we have to find the value of limit for x. So we need to find the area region bounded by the y square is equal to 4x, the y-axis, and the line y is equal to 3. The given equation of the curve is y square is equal to 4x. This is the parabola opening towards the positive x-axis. From the equation, we can express x in terms of y. So x is equal to y square by 4, and consider it as equation number 1. So as we express x in terms of y, so here we take the horizontal strip. Okay, the region bounded by the parabola x is equal to y square by 4, the y-axis, and the line y is equal to 3. Since the parabola opens towards the positive x-axis and we are considering the y-axis as boundary, the area will be in the first quadrant, as we already saw in the graph. The y value ranges from 0 to 3. Okay. The area of the region given by def integral of x with respect to y from y is equal to 0 to y is equal to 3. So if we show in the graph, the limit for y is y is equal to 0 to y is equal to 3. So area is equal to 0 to 3 x dy. Substitute this expression for x from equation 1. So area is 0 to 3, x is y square by 4 dy. So now we have to calculate this definite integral. Take the constant 1 by 4 outside the integral sign. That is, area is equal to 1 by 4 definite integral from 0 to 3 y square dy. And to integrate y square with respect to y using the power rule of integration, that is integration of y the power n dy is y the power n plus 1 by n plus 1 plus constant of integration. So area is equal to 1 by 4 y the power 2 plus 1 by 2 plus 1, and the upper limit is 3 and lower limit is 0. That is 1 by 4 y cube by 3, and the upper limit is 3 and lower limit is 0. Now you value of any derivative. Apply the second fundamental theorem of integral calculus. Substitute the upper limit and lower limit at the value of any derivative. You get 1 by 4, 3 cube by 3 minus 0 by 3. That is 1 by 4, 27 by 3. So when we simplify, we get 27 by 3, that is 9. So 9 by 4. And that is the value of the area of the region bounded by the curve y square is equal to 4x, y-axis, and the line y is equal to 3. Okay. So comparing with the given option, option B is the correct answer. Okay. So in today's class, we solve some question how to calculate area of the curve bounded by some particular lines and how we use definite integral to calculate this area. That's all for today. Thank you.